Alright, so here we're giving the definition of the average rate of change between 2 points. And as we've seen in the example done in class, it's easy to think about when we have real life values, but we want to have a concrete conceptual understanding when we go and we deal with different situations. So the average rate of change between 2 points for a function f of x, the average rate of change between a point at x equals a and a point at x equals b is given by. And so we want to kind of conceptualize and understand what's happening. So let's imagine here's point A and here's point B, and these are the two data points that I have. And I want to know the average rate of change between them. In other words, I want to know about how much is it decreasing, is my function decreasing, because I can tell it's clearly decreasing here, it's going down, every single unit. In other words, how many am I decreasing every unit to get to the final point that I reach? And so what we're asking is, okay, well, what is the rate of change? What is the slope of the line that gets us from A to B? That incrementally over every x step will get me to B. And what we've seen in that past example is what we did is we found, okay, how much has it actually changed? What is the change in the y direction? And once we found the total amount of change, we then said, okay, and over how much space has that happened? The change in x. And when we divide those two, we are finding the average amount that it's changing every step of the way. So the question now is, how do I compute this change in y? Well, think about it. When you are thinking about how much something has changed, you take the value that you ended up at. Where do we end up here? We end up at f of b, right? The x value b is what we plug in. And where did we start? We started at f of a. And so to find the total amount that we've changed, we're just going to take f of b and subtract from it f of a. And that'll give us the total amount of change that's happened, but we want to know on average how much is it changing every step of the way. So we want to split it up and divide it by the number of x values that this change has taken place over. And that is going to be the distance between b and a. So imagine that a is 1 and b is 2. The difference is going to be 2 minus 1, right? So in this case, it's going to be b minus a. And that is the average rate of change between 2 points. Alright, so now we're going to do an example where we can apply our definition for the average rate of change. And the question says, find the average rate of change of the polynomial y equals x cubed minus 25x squared plus 4x minus 20 on each interval. And so the two intervals they give me are 4 to 5 and negative 4 to negative 1. And so I first want you to just think about what is meant by the question. Maybe draw a quick little sketch for yourself, and then when you think you have a good idea of what the question is asking, go ahead and press play again. All right, so hopefully in your mind you're envisioning this sort of situation here. We have the points 4 and 5, and we also have x values of negative 4 and negative 1. And now I don't know exactly what this function looks like, because I'd have to graph it out, and I could do that. And I know it's a cubic polynomial, but for our sake, let's just imagine that we have 2 points between negative 4 and negative 1. We also have the points at 4 and 5. And if we want to find the average rate of change, we want to know about how much is it changing every step of the way between those 2 points. And so if I go back to my definition, this is pretty clear, right, that I want to know the values at each of those points. So f of negative 4 and f of negative 1. I also need to know f of 4 and f of 5. And then I also need to take, okay, say that I have those values. I need to then find the total amount of x space, or x values, that I've traveled. So really I'm finding the change in y over the change in x. Okay, so let's start with a here. The interval from 4 to 5. And so if I want to find the rate of change, the average rate of change between the interval 4 to 5, I need to find the value that I ended up at, 5, and I need to subtract the value that I started at. In other words, I need to find the change in the y direction, and I need to divide it by the change in the x direction. Well, what is that? It's going to be the value when I plug in 5 minus the value when I plug in x equals 4. And how many x spaces have I traveled? Well, I ended up at 5 and I started at 4, so 5 minus 4. Now I'll leave it to you to compute f of 5 or plug in 5 into my function and find out what the y value is. And you can do the same for f of 4. Why don't you go ahead and pause the video and do that, and when we come back we'll take a look. Alright, hopefully you found that f of 5 is going to be negative 500. We're going to subtract, and f of 4 was negative 340. And of course this is all over 1. When I compute that, negative 500, and then the negative times the negative makes this a positive. So we have a negative 500 plus 340. We're going to end up with a negative 160, all over 1. And that's simple. That's going to be negative 160. So the average rate of change is 160, but in which direction? Well, it's going down. All right, so if I were actually looking at my graph here, this would be an inaccurate representation, right? Because I really should be going from f of 4 down to f of 5 by about 160 every x trip. All right, let's go ahead and take a look at B. So here I'm looking at the interval negative 4 to negative 1. And what I want you to do is pause the video and see if you can set up how you would go about finding the average rate of change between these 2 points. And then when you're ready to go, press play. Alright, so hopefully what you're thinking about is, okay, if I started at negative 4 and end up at negative 1, about how much am I changing every single x step? In other words, if I start at negative 4 up here, what's my average change every time I move 1 in the x direction? That's what we really want to conceptualize here. Every time I march 1 step over in the x direction, on average, how much am I decreasing or increasing? Okay? And so what we're looking for is, well, the change in the y direction, how much am I going up or down, and over how much x space is that happening? And to find that, we're going to find the change in the y. In other words, where was I at when I was at negative 4? Where was I at then when I got to negative 1, and what's the difference? So f of negative 1 minus f of negative 4. Remember, I take the value that I ended up at minus the value I started at, and I'm going to divide it all by negative 1 minus negative 4. I want you to go ahead and compute that for yourself, and then when you are confident in your answer, try and put it in your own words. What does that mean? And then come back. Alright, so hopefully you found that f of negative 1 minus f of negative 4 gets you to 450 over, and negative 1 plus 4 is going to be 3, so we're going to get 450 divided by 3, which is exactly 150. So now when you put it in your own words, and if you haven't done so already, try and do that right now, and then press play again. What that means is that every time that I move 1 unit in the x direction, I am increasing 150 in the y, right? It's the average amount of increase or decrease in the y direction for every step in the x direction. To give you a really concrete analogy, imagine you want to know the number of points that you're averaging over the course of a 5-game stretch in the basketball season. Well, you're going to take all the different points you've scored, you're going to add them all up, and then you're going to divide them by the number of games you've played. Right? So you want to know, on average, for each game, how much are you going to score, And that's the same thing here. We want to know, on average, for each step in the x direction, how many units are we going to move either up or down. And in this case, it would be 150. So the last thing we want to do is we want to compare these two rates of change here. And I'm going to move this up just a little bit. And so the two rates of change that I have, for part A, I got a rate of change of negative 160, and for part B, I got a rate of change of 150. Now, clearly, well, actually, I want you to pause right now and compare the two to yourself. Hopefully what you realize is that even though part A gives us a negative rate of change, so it's decreasing, this is actually a greater change than it is here. Think about it this way. Who's changing more? Someone that is going upwards 1 foot every minute, or someone that is going downwards 10 feet every minute? Obviously the person going downwards 10 feet, because that's a huge amount to change every minute compared to the 1. And so we can see here that it's actually a decrease of 160 versus an increase of 150. And so if we were to compare the two, we would say that while A is decreasing and B is increasing, A is a greater rate of change because it is changing by a larger amount.